Hi there, scientists. We're going to start talking today about energy. First, thought I'd show off my bright orange University of Tennessee shirt in celebration of Generation Texas Week. We're all wearing our college colors, so this is where I graduated from quite a long time ago from the University of Tennessee for my bachelor's degree. So let's talk about energy, the different forms of energy is probably something that you're pretty familiar with because you've been learning about those since, oh my goodness, 6th grade. So I think maybe just kind of listing the different forms of energy would be a good place to start. I'm going to make them over here, kind of just like a little tiny checklist. You could make that too if you'd like. So just forms of energy, and I'm just making a little checklist because I'm going to check these off here in a second. So a couple different forms that maybe you remember of energy, and feel free to pause me and maybe write down as many as you can remember, and then start me back up again and see how many you were able to think of. But I'm going to write down the different forms of energy that hopefully you've learned about. One would be electrical energy. I know you learned about that last year when you were studying circuits, so electrical. Another one would be heat, is what you called it probably in the early grades, and then maybe you've kind of graduated to calling it thermal energy. And then another one that you would know is mechanical energy. And of course there is light energy. Another name for light energy, which is a word we'll be using this year, is radiant energy. Sometimes if it's coming from the sun, we'll even say solar energy. So all of those would be forms of energy. Another one that we spent a lot of time on in our chemistry unit would be chemical energy. And the last one that's kind of new to us this year would be nuclear energy. All right, so those are just kind of the different forms of energy. And if you took those notes, great. If not, they're going to show back up over here on the big part of the board. Because as we learn about energy, we're going to take those forms and break them up into 2 categories of energy. So this is where you definitely want to start taking notes. Energy, oh, not with that marker though. Energy and be broken into 2 categories. But before we do that, I'm going to make this look energetic here. Energy. I'm going to write down first what energy is not. Energy is not matter. So remember when we were first learning about matter and we were like, everything is matter. And we were like, oh, no, not everything is matter. Well, energy is certainly not matter. And there's a lot of energy in the universe. And you've learned about a lot of different types of energy. And it's not matter. Instead, what energy does is energy can change matter. Or we say do work. So they're related, energy and matter, and there's energy in matter, and energy can change matter, but it's not matter. It's something altogether different. It's the ability to change matter or the ability to do work. 2 big categories of energy. We have kinetic energy, and we have potential energy. So those are the 2 big types. I'm going to just add a little color because, you know, it's fun. So hopefully you've got some colors when you take notes. at home, kinetic and potential. So now I'm going to define each of these categories so we can think about how we want to put those different forms of energy underneath each one. Kinetic energy is defined as energy of motion. So anything moving, anything with motion has kinetic energy. Potential energy is stored energy, or we could say energy of position. Position or even of shape, because depending on your shape, you may have potential. These two are related, potential and kinetic. They can change from one to another. So I'll give you an example here with a rubber band. So it's got potential. There's energy stored in this rubber band because of its shape and position. And I can add more and more and more potential to it if I'd like. Of course, I could change this potential into kinetic, and you know how, right? And then it would move, and I would have changed potential to kinetic. So these can transform or change into one another, just like I did with the rubber band. It went from potential to moving, so potential to kinetic. All right, so that's the difference between those two. Those are our two big categories or groups of energy. Let's go here to our list and think about which ones would go where. Now again, you could pause me and try to sort them on your own. See if you could decide where you want to put electrical, kinetic, or potential, or heat. Is it kinetic or potential? So pause me if you want to give it a try, and I'm going to go ahead and tell you right now. Okay, I'll start with electrical because it's first on the list. Electrical, kinetic. So electrical is kinetic, and think about that. That makes sense, right? You learned about circuits last year, and you know that when you close the circuit, that the electricity flows in a circle around the circuit, right? It comes out the negative end of the D cell through the light bulb and maybe the switch and back and around. And there's circuits all over your house where electricity is flowing or moving. So electrical would be kinetic. I'm just going to draw for fun here a little circuit so I kind of remember about how electricity flows around my circuit, which reminds me that it's moving. I always put those little arrows even to show that. And even lightning, right? That's electrical energy, and it's moving if you've ever seen a lightning strike. So electrical is kinetic. Heat or thermal energy? Kinetic. So thermal energy is heat, and it travels. It can move, right? If you've ever put, I don't know, something metal, maybe like those skewers that you use to cook the marshmallows over the fire. Well, first of all, you feel the heat travel. Ooh, it's hot around the fire, so it's moving. And then even if you've got that metal, and like, ow, eventually it gets hot because the heat is traveling or moving, being conducted up your metal stick that you're toasting your marshmallows on. So this would be energy of motion. Heat is the energy of moving molecules, and the faster the molecules move, the more thermal energy they have. So gases, right, where the molecules are really spread out and they're moving a lot faster, have more thermal energy usually, especially if they're warm gases. So thermal goes over here, and I get to check heat and thermal off. Mechanical I'm going to save for last, so I'm going to jump to light. Light energy, kinetic or potential? Does it move or not? Well, light sure does move. It moves at the speed of light, 186,000 meters per second. That's pretty fast. So it's definitely traveling. Light travels 93 million miles to the Earth from the sun. So it is a moving form. It is kinetic energy, light. All right. Chemical energy. We spent a lot of time in our chemistry unit on chemical energy. Is that stored up energy or is it energy of motion? Well, over here with chemical energy. Chemical energy is the energy that's stored in the bonds that hold the molecules together. So for example, if we had like carbon dioxide, the energy's here in the bonds that are holding the atoms together. When we do a chemical reaction and the bonds break and the atoms rearrange, well then they release energy, just like the way the rubber band has potential and it turns into motion. Well, when we do a chemical reaction, we might release heat, exothermic, right? Or other changes can occur when we break those bonds and the atoms rearrange. So they have potential. Hang on one second. I'm just going to get something over here, some leftovers, just to kind of make the point still, right? This stuff could sit forever, the baking soda and the vinegar, right? On the shelf at the Kroger, it could sit like this in my cupboard over there. Nothing's gonna happen. There's nothing moving. There's no reactions occurring. It's got potential. If we combine them, we can let the atoms rearrange, the bonds will break and we'll release the energy, but not like this. They're just chemicals, chemical compounds waiting with lots of potential. Your food that you eat, I don't know what you had for lunch, for dinner, let's say you had a piece of pizza. Pizza's chemicals, right? There's proteins and fats and carbohydrates bonded together, all those atoms to make those chemical compounds, yum, 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 in the pizza. Well, once you digest, that's a chemical reaction. The bonds break in here and the atoms rearrange and release thermal energy. That's why your temperature is always 98.6 degrees Fahrenheit. That's why you have energy to run and to play. And electrical impulses going through our brains so we can think right now. All that chemical energy gets changed into kinetic energy when we break the bonds in digestion. So chemical energy, potential. Check in the box. Boom. We've got nuclear and mechanical left. I said I'm doing mechanical last. So nuclear. Didn't get my poster. Maybe I'll turn this. Can you see if I go like this? Let's see. If I can turn my tripod. Oh, look at that. I don't know if you can see my poster though. It's got a weird glare on it. Over here, my poster. Well, it's of an atom. And that's the nucleus of the atom. And in the nucleus of the atom is stored a lot of energy. Nuclear energy that we could have a nuclear reaction to release. So nuclear is stored energy. It's stored in the nucleus of an atom. And we can release that in a nuclear explosion. We can do it in a nuclear reaction to generate electricity. We could use it in a nuclear submarine. All we have to do is either break apart the atom's nucleus or smash two nuclei together. Two different things. If we break it apart, that's called fission. We split the atom and release the energy that way. Split it. and that energy gets turned into light and heat and all kinds of crazy things. Or we can do the combining the two atoms together. It's called fusion, and that releases a lot of energy too. This is what we do, humans, with our nuclear power plants. We do fission. We take really big atoms and we break them apart. We don't know how to do this so good yet. We're learning, but that's what stars do. That's how they create so much light and so much heat, is because of this kind of a nuclear reaction. They're fusing it together. So there's a lot of potential in all those atoms that are in the stars. All right, so that's potential. Check that one off. Now I come to mechanical. That's the last one left. Mechanical's weird. It's both. So I'm going to put it in the middle. Mechanical. And I don't know, I'm going to put a little blue on this side and a little red on this side to show that it's both kinetic and potential energy. What it is it's going back and forth. So like the rubber band, potential, kinetic, potential, kinetic. So it still has potential in the shape, right, in that elasticity that's in it. Potential, kinetic, potential, kinetic. Running, or anything that we do like physically, even in our muscles, we contract our muscles, we build up potential, and then kinetic, potential, kinetic, potential, kinetic. Same thing in a bicycle or machines. They're just alternating back and forth, potential, kinetic, potential, kinetic. Storing it up, letting it go. Storing it up, letting it go. That's how things move. That's how we design machines. That's our body is a machine that works that way with mechanical energy. So it goes back and forth. I'm going to put a PE here, just kind of like, that's a short way that we write potential energy. And a KE here, that's kind of like the short way that we write kinetic energy, so that I can do this. Kinetic energy and potential energy. Oh, that's that bad marker again. I better throw it away. Oh well. I'm going to use blue. Potential energy. Just kind of going back and forth, right, with those. All right. So those are our notes for today. And what you're going to do today in your investigation is explore this a little bit. Explore mechanical energy, how we convert potential into kinetic with an investigation with rubber bands. So hopefully you'll have some fun with that and learn some more things about energy. All right.